afternoon. Happy Native Prairie Appreciation Week. Welcome to Prairie Conservation Action Plan Speaker Series. My name is Caitlin Morose and I am the Stewardship Coordinator with Saskatchewan Prairie Conservation Action Plan, or PCAP. This week is Native Prairie Appreciation Week. Saskatchewan is the only jurisdiction in North America that proclaims Native Prairie Appreciation Week, which is devoted to raising awareness and appreciation of native grasslands. Earlier this year, SKPCAP and the Society for Range Management Prairie Parkland chapter were planning a native prairie tour when the pandemic derailed the plans. So we've decided to have the elements of our tour available as webinars, including presentations related to native prairie and some training opportunities. This afternoon's webinar is about the Saskatchewan Ministry of Environment's Prairie Landscape Inventory Project. Mapping the remaining native prairie in Saskatchewan will be delivered by Nasem Badreldin, who is a landscape modeling scientist with the Saskatchewan Ministry of Environment. And just a few housekeeping items before we begin. All of the Native Prairie Appreciation Week Speaker Series webinars are recorded and will be available on PCAP's YouTube channel. And just search YouTube for SKPCAP and you should find it. Everyone is muted. If you have any questions during this presentation, on the webinar pop-up, there's a place to type in questions. And at the end of the presentation, I will be moderating them, but feel free to type in your questions at any time during the presentation. There are 2 more webinars this week, one at noon on Thursday by award-winning author Candace Savage, and Friday at noon will be about prairie plant ID. The Friday webinar is full, so make sure if you register to sign on early and get a spot. There's more information about NPAW and the webinars on PCAP's NPAW webpage. In addition to these webinars, there's also a native prairie photo contest going on PCAP's Facebook page. And if you have a few minutes, please check out the photos and vote for your favorites. There's also a checklist on PCAP's website where you can find more information about experiencing native prairie during a global pandemic. I'd also like to note that we have a Native Prairie Speaker Series webinar on June 22nd about invasive feral pigs in Saskatchewan, and you can register for that one through the PCAP website. I would like to take a moment to note that in-kind support for this project has been given by the Saskatchewan Ministry of Environment. And now a bit about today's presenter. Dr. Nasem is a landscaping modeling scientist. He received his doctorate in geography from Ghent University in Belgium in December of 2013 and his master's of science in physical land resources from the Faculty of Bioscience Engineering at the University of Ghent. He worked as a postdoctoral fellow at the Center for Earth Observation Sciences in the Department of Earth and Atmospheric Sciences at the University of Alberta and the Department of Soil Science in the University of Manitoba and the University of Guelph. He is a professional in land cover mapping using machine learning algorithms, remote sensing data, and advanced spatial statistics. He is now working for the Ministry of Environment in the Fish, Wildlife and Lands branch at the Government of Saskatchewan as a GIS analyst. So with that, I'd like to pass it over to Nasem.
Hi, thank you very much for this introduction. My name is Nasem Badreldin, and on behalf of my team, Beatriz, Prieto, and Ryan Fisher, I would like to thank you all for inviting us for today's talk. Today's presentation will be mapping native and tame in the mixed grassland ecoregion using machine learning and big remote sensing data. I joined in last year, February 2019, the Prairie Landscape Inventory team. And the first thing we have stated as objectives for our project is to create innovative way to distinguish between the native and the tame grasslands in the south first, as the south of the divide in Saskatchewan. Though furthermore, with discussions, we found that increasing the case study would be very much grab the attention and will be beneficial for everyone in the ministry and for the community as well. Though we decided to go for the mixed grassland ecoregion. So today's presentation will take you through several steps. However, this presentation is made for the non-professionals in GIS and remote sensing, but of course you are more than welcome to ask me any question between the mapping, the modeling, and all the process that we have done, and probably I'm not gonna say it all here. So first we will start with the rationality, why we have done this, what are the motivations that drive us to do this analysis, but also we would like to show the trend of the scientists and the publications in the past 25 years. Also, we will discuss the case study, the dimension of this case study, but also we would like to discuss the nature of this big data, since it becomes very important and it will become very vital in the next couple of years with the 5G technology. Also, we will be introducing the machine learning algorithm that we used and how we used it briefly, but more emphasizing to the land cover spatial distribution and how much is the native and the tame and the croplands in the mixed grassland ecoregion. One of the most important parts of our presentation as well is the data reliability. How much can you trust our analysis? How much can you trust the classification? And then for the future steps of our project, collaborations and sharing information and data. And I would like to end this presentation with the take-home messages for both people related to keen about the environment and agriculture, and also the technology of such work. So the research rationality, we all know that the native grassland, it is one of the most important indicators to assess the ecosystem health in the prairie. It is, beside that, the home of several species at risk. So we know that there is this kind of fight between the human and the natural factors to take from this natural landscape via the agriculture conversion and transforming these lands to agriculture activities, but also the environmental impact is quite tremendous. As yesterday's presentation stated that the soil erosion also was one of the major impact in our landscapes in the Saskatchewan, but also looking at the drought and the invasive species as a potential risk. So it became very important for us as scientists or specialists to provide the decision makers with accurate numbers so they can build a better strategies, mitigation strategies, and conservation strategies. So it's all relying on accurate numbers. So looking at the past 25 years, we discovered that there is a decline in the trend of interest of publishing and doing research in such field. However, the trend is really surprising because there is a tremendous increase in the technology and the ways of analyzing such information. Though this is a survey I have done last week from the Science Direct or Elsevier publisher as one of the peer-reviewed scientific journals in keywords of native grasslands and ecosystem conservation. Though I found that there is a trend of decline, but also the share that we, let's say for 2019, that Saskatchewan contribute to this is quite low. So there is about 14% of what have been published by Canadian institutes in the 2019 related to the native grassland research, which is also argue how much it is important to introduce and to increase such projects and such research. Of course, we have our colleagues and in the province, they have done a great job publishing such a tremendous and important papers. It helped us to develop our research now and to provide even more techniques and reliable information. So our case study is the mixed grassland ecoregion. It is about 13% of the Saskatchewan size. It's about 8.6 millions of hectares. This massive big area, it contains about 25 landscape areas. And these areas are quite diverse. So they are different in chemical and soil physical soil properties, and also in the soil moisture content, soil organic matter, the landscape, and also the rainfall and the precipitation, the climatic conditions. So they change with this spatial extension. It become quite challenging, though we took to our consideration seven classes, land cover classes we would like to map. More importantly, the native, tame, and the mixed grassland. These are the more important land cover to class to do the classification for. But also the croplands and the water ponds are very crucial to our analysis. However, the shrubs and the trees, they were not included in the classification algorithm. They were developed by extraction information from the agriculture agri-food landscape inventory, though they have it for 2016, 17, and 18. So the native grassland, it's primarily the native grass species, such as the needle grasses, the wheat grasses, along with the western wheat grasses, also the blue grama grasses. Though the mixed grassland is quite challenging because we put some conditions to this kind of mixed grassland. It is a combination of a mix of less than 75% of native grass and less than 75% of tame. But also it can be tame and native grassland affected by high abiotic stress, such as soil salinity or drought. So it means that there are some bare ground exposure though. Also areas affected by soil erosion, such as the water erosion or the wind erosion. So these are the conditions for the mixed. For the tame, representing all the species that contains the tame and defined by our biologists. But for example, the Russian wild ray, the crested wheatgrass, etc. So there are quite range of species we included in the tame as well. Croplands, most of the cereal crops, the oil seeds, the pulses, and others. And the water class contains the lake, rivers, water ponds, even the dugouts, and some lower elevation in the irrigated areas. So thinking about the life cycle of big data, actually we give this name to our big data because we think about the data that we have, it's like a living creature. You start with a certain dimension of information, but along with your analysis, it grows up with you. So start with the birth of this data as it is the data acquisition, which is very important and very crucial. And this is what we will describe later in this presentation, especially for such project. Data pre-processing and assessing the quality of your information. Data modeling, you know your capacity, you know the algorithms that you're gonna use, you know how big is your information, and you would like to adapt your algorithm to it. But one of the most important parts at the end of any work like this is the validation after, of course, the layouts, the mapping, and the statistics. How much can we trust this information? So how big is the big data? There is a debate between the scientists, especially in this sector, especially in the land use land cover mapping. But what we found is over 500 gigabytes can be considered as big data, since it can grow with the time. In our particular case, our data grows up from that stage to 2.3 terabytes, which is quite challenging, especially if you have quite limited infrastructure. So as I always said, consider yourself Alice in Wonderland, and don't go or intimidated by this little cookie said, eat me. Though you will find yourself growing up and enlarging in a certain fixed dimension that you can go out. And this is the problem with the big data in such research. So in order to avoid this kind of dilemma, you have to think about 5 things: the available infrastructure you have, the time needed for your project, the storage capacity that you can handle, the workflow process that you have or your institute can provide, the required skills in your team. So if you have programmers or just GIS users. So for training or building a robust artificial intelligence algorithm, we started by taking the south of the divide as a pilot site, because we have enough from previous years of enough field work, about 600 visits, intensive field works from our colleagues in the past few years. But also we adapted a new way of minimizing the biasness in the field and try to get extra accurate information, so we can train this artificial intelligence more carefully in order to get more accurate results. So within each plot, we adapt about 12 replicas. These are quadrant that can be judged, as you can see in this picture, by 3 well experts in the native grassland. And the purpose of this is to start the analysis, making sure that you are representing the exact class, even if there is some errors in the locations or any occurring error, but you still very confident that you are representing the exact spot that you are picking, or give it a name. So that's one of the issues. Though we started as a pre-process for everything, collecting information from modest satellite. This is a type of satellite that give some sort of coarse spatial resolution, but with some varieties of spectral resolutions. As modest, we obtained about 18 years of information of 16 days time interval. The resolution at that time, it was like 250 meters. And for the purpose of knowing when is the time to do the data acquisition for the purpose of our analysis. So the purpose is to classify the tame and native, but we need to understand which time is the most suitable time to do the study, at least for mapping and doing the classification. So with the time series that we generated, we could understand that even June is really providing such important, such distinguish between the classes. But we discovered that the mid-July to mid-August would be more suitable, since we are going to use Sentinel-2, which is optical kind of satellites, depend on the clear skies, not like Sentinel-1, which is almost a radar, but also the DTM generated by the AFC with about 19 meters spatial resolution. We do believe that this resolution is interpolated. So probably it's 30 meters spatial resolution, but it's interpolated to downscale it in some sort of way. Further, but not in depth, also looking at some pre-statistics that we used in order to select these variables. We would like to ease or to decrease the number of samples in the analysis, or the number of variables in the analysis, so we could have an easy time processing our case study, at least the pilot site, to train this machine learning. So we used for that the principal component analysis and the linear discriminant analysis. With this figure, as you can see, the NT, which is representing the mixed grassland, expected to be the troublemaker in this analysis, because of course it takes from the native grassland and it takes also from the tame. But we found that it is important to leave the mixed grassland in the analysis, so we can have an idea of probably a transaction between a landscape status between the native to the tame, or degradation in the land, or any other concerning scenario can be even analyzed further as in the change detection. So all the purpose of this simple flowchart is just to go for the random forest classifier, which is one of the machine learning algorithms. It's based on a decision tree, but imagine that we have more than or about 500 decision trees. Looks like a forest. So it's about 500 decision trees the purpose of it is to take all the variables needed based on the trainings that we have and to give us some classification to the analysis. Though we challenge ourselves to go even further with the analysis, we collect about, or we actually calculated 75 variables between Sentinel-1, Sentinel-2, these satellites provided by the European Space Agency, and also the DTM provided by the AFC. We wanted to touch the maximum of variables as we are going to select from them the most effective ones. As a conclusion of this kind of pre-analysis, before going for the classification, we found that surprisingly, actually, that the NDVI is not one of them and other variables, though these are the 10 variables that can create this distinguish between these classes. Croplands, lowland will be transformed later or join the mixed in some sort of way. Native grassland, the mixed grassland, tame, and the water bodies. But also part of this work, before or even sending the analysis to the machine learning, we've been taking this 10 variables and try to change the combination between them and see how that affects the accuracy of the classification. So if we can feed the analysis with 10 variables and gives us the same accuracy of 5 variables, that would be the choice to go with less variables, though we need to slow down the processing time and to take the data size into our consideration. So as part of the pre-analysis to our pilot site, we generated this map for the part of the sod, though the assessment for the pre-analysis for the pilot site was really encouraging. It helped us to expand and to test these 10 variables along with a certain combination in order to do the classification for the whole mixed grassland ecoregion. So as a final product, this is the mixed grassland ecoregion map that we generated. We found within this analysis, within this case study, 52.2 of this case study is cropland, 33.9 is native, the mixed were 4%, 2.3% are tame, and the water is 5.5, etc. Though we created also a dashboard, I would like to show you here. I hope it will. Yeah. So this dashboard will give you even more details related to the landscape areas. And of course, it will give you how much can you trust this information. So let's say that you if you are going for this landscape, it will tell you that you can trust the analysis that you're gonna see right now with 81.03% accuracy. So you go there, you know how much native, in hectares, of course, these numbers, how much mixed grassland, shrubs, trees, etc. Of course, you can go even deep to know how much the native combination or the share within this landscape, which kind of landscape has more native grassland and more tame or more mixed. Of course, I mean, it's just a quick demonstration of the detailed information we could gather from this. So we made some correlations between these numbers and some published numbers, though we think that we have done really careful analysis during this research. And as I'm going to describe later, we really criticize our product in different ways because we do believe that no one can produce 100% accurate information like this with this much of details. So we would like to give this information a reliability number. How much can you trust this classification for different purposes, I will say later in this presentation. During the field work, we took in our consideration that we will come to this level, though we make sure that we capture tens of pictures and drawings even in the field, trying to correlate what we have in the map, to connect what we have in the map with the reality. It has to represent the reality in some sort of way, in some point, as you can see. There are sometimes some challenges, but at least we are making sure that we are capturing this spatial heterogeneity and identifying where are the sources of error for future development. As you can see here, well, these are random photos connected with the analysis that we have done. So it captures in some point the lowland, where it can be a mixed or native grassland. In dry seasons would be exposed as a native grassland, but in wet season can be merged by water or become a wetland in wet seasons. So it's a dynamic landscape that can change with time. But also we would like to show the challenges that we might face. As you can see in the first picture, it captured the lowland as it is, but in just nearby, as you can see in picture B, it doesn't capture that. It captured it as a mixed grassland, though maybe because of the differences in the soil moisture content, maybe the differences in the soil organic matter that makes the vegetation looks even healthier, or other factors needed to be investigated in the future. So as part of our analysis, we wanted to show how much accuracy we have. As an overall accuracy, as you can see in the first figure, figure A, as the HU, which is the habitat unit, we have an overall accuracy of 90.2%. Comparing to the AFC Agriculture Agri-Food Canada maps of 2016, 17, and 18, we capture higher accuracy. But overall accuracies is not the full picture. You need also to look at the classes themselves and see where are the classes that produce less accuracy in order to develop in the future. Croplands has the highest accuracy, but mixed grassland, as I pointed out in the earlier slides, they were expected to have lower accuracy, but with acceptable number. Based on publications, the best or the acceptable accuracies can be 70% or more. So we found that confusion statistics or any statistics is not such important, or it's not as important as also the experts' opinions. We needed at that time experts' opinion to tell us how well our classification is. And for that, we developed an application I will show you later now, in order to see the judgment, because they can or they may be different, as in this C figure. So you can see, even though we have in the native statistically 88.4% accuracy, but still the experts think that we capture an acceptation of 73%. Surprisingly, also the mixed grassland, in the point of the experts in the province, that we captured correctly was 95%. The statistics is saying something a little bit different. Though for that purpose, or as a result, we have an application developed by our colleagues in our ministry. I will show you.
Nasem, I don't know if you can hear me, but we can't really hear you right now. You might have muted your mic or...
I'm not sure what happened there. I will just send Nasem a message and see if I can't hear anything either. To our listeners out there, if you don't mind bearing with us for a second while we just... Oh, hi.
Hello?
Sorry, we couldn't hear you there.
I was talking. Okay, so sorry. I don't know what happened.
Do you want to go back a slide or two?
Okay, this one?
No, you were just when you opened the application, Nasem.
Oh, okay, okay.
That's when we lost your sound.
Okay, so sorry for that. Okay, so thank you. So going back to the application, so this kind of application help us to grab opinions, experts' opinion on our work, and looking at different classes and try to give us their feedbacks as part of the analysis and assessment that we are trying to do. These judgment or these numbers are based on a recent publication in 2020 by a professor in statistics and mathematics in Nottingham University in UK. So going back, so now we can provide you also not just with the classification map of the native and the tame grassland, but also we can give you the reliability map. How much can you trust our product, and also where we can develop more in the future, and we can enhance this accuracy in the future. So as you can see here, it's high or more accurate in this sites, but these sites require more visits, and especially these kind of hot colors. So going to the future steps of our research, our work, we wanted to include new case studies. We wanted to expand our research, not just for the mixed grassland, but for the whole prairie ecozone, moist mixed grassland ecoregion, and etc. And this is the good time for us to expand and to collaborate, since we just finished a product. And we still have the vital or everything, the platform, the softwares, the skills, and everything. So, and also we need these collaborations as for the validation outcomes. We need to validate more, and we keep validating. And for that purpose, I will show you now a simple survey application that we developed. Also sharing information. Since I started this project, we've been sharing the information, the thoughts, the developments. Luckily, last year in July, we presented a poster at the Canadian Soil Science Society, and in September, we presented again our work in another society, scientific society, and etc. So we are into sharing information and sharing thoughts and trying to come up with new ideas and to enhance this product, and of course discussing the results. So part of our collaboration offer, if you think you can contribute to this project by adding when you are in the field some field survey points, this is a simple application we have. And I don't know, this YouTube we made just to show you how quick the survey can be, and within even 30 seconds you will be able to provide us with your information, and of course with a certain accuracy. It's provided by everyone. If you need, if you would like to join us in this, we'll be happy to get your request, or you can send email to Bea as well. So we have a username and password available for everyone. So going again to the presentation, I wanted to end this presentation with the take-home messages. It's a mix of messages. I'm keen to put it on the table for further discussions probably in the future. The first one is selecting the temporal window for the research, especially for the native grassland. It's quite crucial. And of course, we need to emphasize, we know that we have too many experts here. They know exactly when they should be in the field, but we need to quantify why we are going this time in the field. And to fix that in the future if we would like to do a time series of analysis. We also look at the data source as it is a good opportunity to integrate information from different sources. So if you have a drone imageries, if you have a radar, LiDAR, optical or spaceborne imageries, it would be nice to integrate all these resources. This kind of integration will provide higher accuracy. Using pre-statistics, like for selecting and choosing variables, is quite reducing the stress on the processing or the modeling phase, especially if you are using a big data. In our case, as I said, was like 2.3 terabytes. So using the linear discriminant analysis or the principal component analysis helped us to shrink the number of variables that we put on the table in the first, in the starts. Big remote sensing data, it is coming. There is no way we can avoid it, especially with the 5G technology, though we need to adapt ourselves for intensive data management and quality assessment, because with this big data, it's possible that we can get, as I call it, I'm sorry for the name, but it's can call it as a rubbish information. It's not validated and it can ruin the whole analysis. So having a prop kind of process would help to increase the accuracy, especially for the native grassland mapping. The mixed grassland showing that it has been as a more challenging to be accurately, classified using the random forest. However, we're still confident that the native and the tame grassland that we mapped is the highest possible accuracy we could provide with this kind of data set. Now it's a great opportunity, we think, to extend our work to the prairie ecozone or other ecoregions, like the moist mixed grassland ecoregion. And looking at this opportunity, it's also think about 2 or 5 years from now, if we have every year's map for the native, though we can conduct a change detection, knowing exactly how accurate we are, assessing exactly the trend of the native grassland changes, increase or decrease, though we can adapt ourselves and try to save ecosystems and provide a better mitigation strategies. So with this, I'm very lucky to be and to join a wonderful team. And also I would like to thank these people. They helped me a lot during this year and provide me with the necessary advice and help. Though Ben, Beryl, Sarah, Scott, Andre from U of M, and Mike, Chin, Ken, Chit, Joseph, Catherine, Maggie, Sarah Lee, and Sarah Ludlow, they help us a lot. And thank you very much. Merci beaucoup. And I will be happy to get your questions. And if I can answer you, Bea here also. And if you can send me an email after that, if you have any further questions, I will be happy to answer. So thank you very much.
Thank you. Thank you very much for the presentation. We do have a couple of questions from listeners. To any of our listeners who do have questions, just type it into the question section of the webinar dashboard. So our first question is from a listener named Irene, and she would like to know, how did you differentiate between trees and shrubs in your classification?
Okay, thank you for this question. I don't know if I said it or not. I think I said it. With the shrubs and trees, since we didn't use the LiDAR, we adapt this information. We borrowed this information, especially the trees and the shrubs, from the AFC maps. So we didn't classify it. We just took it from the AFCs. Because that's the challenge with mapping trees and having a grassland. You could go with the LiDAR, but you can't go with this case study using LiDAR yet. However, NASA provided a sort of regional LiDAR with 15 meters, I suppose, spatial accuracy can be used in the future. But for this case study, for this particular research, we just used the AFC because we used 10 meters spatial resolution of Sentinel-2, which is optical remote sensing, and Sentinel-1 as a SAR, as a sort of radar. Though, yeah.
Perfect. Thanks for that answer. A listener named Natalie would like to know if anthropogenic land cover was taken into account for this analysis.
Well, the human footprint have been considered carefully. However, we are still, with the PLI, we finished that phase thinking about the disturbance can be happened by any reason, regardless if it is a human or climatic impact, But we have another work we are doing using also a deep learning, a sort of machine learning, capturing the human footprint, and which is more the human impact. But for this particular work, as I can show you, I don't know if I hope the internet would be speed. Just give me 1 second. I want to show. There are some anthropogenic activities being captured. Disturbance, you mean, to the land cover, to the native, as it is sometimes introduced by the livestock, if I would call it anthropogenic, or trails, and it can introduce maybe invasive species being captured that is mixed, or let me zoom in. I don't know if you can see me.
Yes. Yeah.
Yeah. So you see here as an example of as a road that this is a mixed. So this dark reddish pixels are representing this mixed grassland, which is probably introduced by human activities, maybe trucks or something. So we capture that, but we don't know if this is the reason or not. For the purpose of this project, we were just trying to classify accurately the native and the tame.
Okay, I think that answers the question. Thank you. Our next question is from a listener named Krista, and she says, can you explain the spatial pattern in classification accuracy? Why do some areas in the northern part of the area have quite low accuracy compared to the expert opinion?
Okay, there are so many reasons for that. Based on so let me say that. In this case study that you see right now, with this reliability map, we have almost 2,516 validation points, okay? And by far, this is the max. This is like, when you compare the 25 years of papers, you won't see that number of validation points. However, there are sometimes challenging locations, like this location, as it shows, or for a budget or time limited reasons, we couldn't go there to increase the number of validation points. However, sometimes you could have more points there, but still you get lower accuracy. And that's probably let's say the landscape at that location might be highly dynamic, change with the climatic condition change. So we might have lower or undulating landforms over there, which can be felt by water in a rainy times, or can be dry, in a drought seasons, though it can introduce this kind of error. There are so many reasons to have such high uncertainty. But for this particular case, I would argue to say that we need more points in these locations.
And that's if I may add to that, Nasem, is that that's why we're asking for collaboration from people that are doing field work in those areas.
Yeah.
If anyone listening in is interested in collaborating with us, we would take the points from those areas that have lower reliability and try to improve the model and also expand it to the moist mixed.
Perfect. Our next question is from a listener named Kelsey, and she says 2.3% tame in your case study area seems low. What constitutes native within the study, and were older tame forage stands counted as native?
Okay, so looking at these numbers, 2.3 tame is low. Well, the mixed also can be added as part of the tame. Also in the croplands part, there are, let's say, hay or fodders can be introduced as part of the planted grassland. So if they are cultivated and irrigated and been taking really good care of, they could be merged in some sort of way to the cropland. But comparing these numbers with others, I don't know. It just, since we are taking so far with the analysis, I would say might be the other numbers are not that accurate. So I would say probably we have 2.3, or let's say maybe we have 3% tame, maybe. Adding to this equation, the mixed. So I don't know. It's well, that's why doing multi-temporal analysis would confirm the results. Well, we confirm our results in a sort of way, like we went to the cropland is the only class we could really compare with the AFC and make sure that we really capture a good number. If we think that we capture exact or almost the same number, that's what happened when I did the comparison. It gives me the sense of, yes, it might be the tame, that number. But looking also at the accuracy, the statistics accuracy from the tame and the experts' opinion that they have so much experience in this field gives us a little bit more confidence. But in the few, maybe if we extend our case study, we might discover that we are misrepresenting a certain class or something. I don't know, but this is science. I mean, probably next year will be someone else with different tools and more data, can introduce more accurate numbers. But at least we are measuring the reliability and the accuracy of these results by a difference of statistics and expert opinions.
Now, Nasem, could you explain a little bit, because I think Kelsey's asking also about what is considered native? Like, was that a 75% native, over 75% of native vegetation? So there could be some tame, maybe in those native areas as well? Yeah,
that's also possible. I mean, doing this work with 10 meters spatial resolution, there are, and there is, I would like, I don't know if I have it here. There are sometimes, I don't know if this can be appeared. Like you look here, let's say in this cropland, and you see a little homoky land over there, and probably let's assume that this is tame, and in the middle there are some, as this map or this snapshot shows, that there is a possible that we have some tame or native in these kind of land cover. Sometimes it's because we are over calculating everything, so we capture every details in this landscape. But sometimes, and it is possible, the climatic conditions or the accuracy of our work. So, but this is something we would love to see in the future. Like we would like to get some statistics from others and see and compare what they have with what we already have.
That sounds great. A listener named May would like to know, what are the levels of accuracy for native versus tame for the shoulders of the growing season? For example, tame grass seems to be greener in April and October in tame grassland versus native. Do you have any thoughts on that?
Oh yeah, and that's actually, before we started the work, as I said, we said we needed to emphasize, like we needed a temporal window. We need to know which time is the suitable time for such research. And that's why we've been moving forward to take 18 years of 16 days time interval, like every 16 days within this 18 years between 2000 to the end of 2018, and to know the fluctuation, the change that happens every year. That's not the only scenario we have done. Like we have done also, and that's what this figure in the middle shows, differentiate, and using the NDVI, by the way, that's a kind of vegetation index, distinguish between the native, tame, and the mixed, and see which one is showing the differences. Yes, I agree with you. Maybe April or May would be showing some promises, and it might provide better accuracy or different uncertainty. But thinking about the whole picture, like mapping native, mixed, tame, cropland, and everything at the same time with this kind of data sets, we thought that based on the statistics that we have done, that the mid of July to the mid of August would be good for us. Adding to this some challenges as a remote sensing guy, the cloud-free time. Do we need to have a clear sky in order to get good data for the analysis? So yeah, maybe if we change the tool, like let's say if we use more regional LiDAR, that would be awesome, though we can detect even the changes within the year.
Perfect. Thanks for that answer. A listener named Glenn says that he would like to collaborate. So Glenn, I'll just get you to touch base directly with Nasem after the presentation. And he also would like to know if you're able to determine biomass from the imaging technology and plant quality.
Yes, the biomass can be determined, but for the purpose of this project, we were really directed to go further with that. But of course, if he has any thoughts about it, well, I will go back to the nature of big data. I mean, time needed is one of the major factors, especially if you know that even after the analysis, we have 10 variables we choose from 75, and from this 10 variables we made a different combination. I remember 13 trials. Each trial can take about a week just to test and see how the model can provide a map. So we don't want to stay 13 weeks. So that's why we've been really focusing not to go further than, but of course, if he has any ideas, he can touch base with me and with Bea. We can discuss even further collaboration. No problem with that. But it is doable. I mean, we can do it.
Perfect, right on, thanks. There's several listeners who are wondering about the estimate of native prairie grasslands remaining in Saskatchewan. At what point can we expect to have an estimate? What are your thoughts on that?
Saskatchewan or the mixed grassland?
Yeah.
So the whole Saskatchewan, it's a budget issue. I mean, we could go with the moist mixed grassland. I mean, that's Bea probably would answer this. Go ahead, Bea.
Yeah, I can take this one. So we're hoping that we can get to the moist mixed grassland region in probably after this season. So probably by winter we would have a little bit the next piece of the puzzle. But to finalize the full prairie ecozone, we think that we might not have enough funding for that. So if anyone has any ideas, definitely get in touch. We will have funding until the end of March this next year. So we'll try our best to keep working on the model to finalize the areas, but definitely if anyone has any ideas about other collaborations or other funding, please get in touch with us.
Perfect. So no estimates about remaining native grassland in Saskatchewan for a while, I guess then.
Yeah, no, not for the full prairie ecozone. Like we would have a bigger area probably by the end of the summer season. That's why we're asking people to collaborate with more points so we can extrapolate the model to a bigger area. But definitely we would need more field work and more points. Like Nasem mentioned, we have a lot of points for these regions that are shown on the map, but definitely for the Aspen Parkland, we don't have as many points, so it would require a lot more field work for that. So definitely the more we collaborate, the faster we can get to the final number of how much native prairie is left in the province. Yeah.
Perfect. Thanks for that answer. There's a few listeners wondering if you can go back to the slide with the app scan link. And then I can also send it out to people as well. Or at the top of your webinar, there's also, if you're on a desktop, there's also a screenshot that you can take of the link too, so you can do it afterwards.
Yeah. Well, I have to mention, if they can have access, I think, if they are within the government of Saskatchewan. Investigating or going, you mean this app? I wonder if this is the application that they would like to see, because
the last slide, I believe.
Yeah, I expected that. So
is the last one the survey 1, 2, 3?
Yes.
Oh yeah, okay, yeah, I will share this, no problem. This is available for everyone. For the password, you can contact me or Bea, and she will give it to you. And there is a manual, and there is the YouTube that I make like quickly to show you how to get the survey within few seconds. So yeah, I will share definitely this with you guys.
Perfect. And I think there is one more question here, it looks like. Listener named Matthew says, this looks like very important technology. What would it take to conduct change detection every year across all ag land in all 3 prairie provinces? It's a big question. Are you still there, Nasem? I hope so, because I don't want to answer the question.
You know what? He's probably daydreaming about how we can do that. Yeah, we can't hear you, Nasem, but that's a big dream of mine too.
I don't know if you can hear me now.
Oh, there you are.
Okay. Yeah, I was dreaming actually. It needs funding. If you hear me, it needs funding, and the skills is there, the data is there. We need funding, I think, because and it's also requires some good infrastructure, and this is something we need to think in the future. Like with the 5G technology, the amount of big data is going to increase, so the infrastructure need to be increasing, as long as with the expertise and sharing this kind of information. So we need funding for such work. At least we will be prepared for the big data, because I'm sure that we will be dealing with big data, but we can't process it, as Alice in Wonderland happened to her when she ate that cookie. Eat me. Though I would think nothing but more funding, and then we can go, I mean, with this, and it's doable. I mean, with the limited resources that we have, we could map 8.6 millions of hectares and provide some measurable accuracy. Though we can do it for the whole prairie, the Canadian prairie. I mean, there is no problem with it. So yeah.
Do you have any idea how much funding would be needed for something of that magnitude?
At least something to keep me working, to extend my contract. But this is something, I mean, I can give you a number, but I would say Bea, respecting the government hierarchy, though I will let Thea answer this.
Oh, I have no idea what it would take to do the full, because you would need to do some more field work. As I said, it depends on how many points you have to ground truth the model. Like the different areas would have different characteristics that you would have to test on the field. You can't just extrapolate the model like that everywhere else. So I can't answer that question. Sorry about that.
No problem. It's a big question.
It is, yeah.
Well, I think that's all the time that we have today. So, Nasem and Bea, I just really want to thank you for your time, for the fabulous presentation today and all of the work that you're doing. To all of our listeners out there, thank you so much for tuning in to our Native Prairie Appreciation Week webinar. And be sure to check out our website and see if there's any other webinars that would interest you. And a recording of this webinar will be available on the PCAP YouTube channel in the near future. And you can also catch other webinars on there as well. So with that, thank you so much, everyone, and have a great rest of your day.
Thank you.
Thank you.